Section 9.3, extra example number 7, less music. We're looking at figuring out if the radio station actually plays less music than they claim. So here are the number of minutes they play music in an hour of a sample of 12 different hours. And so we're going to check the conditions first. So that's R and I, right? So our random condition is we'll just number them 1, 2, 3. So you would say that's the easy part. A random sample of hours was selected. So you can't just write the word random and put a check. Okay, so explain what you mean by that. A random sample of hours was selected. Okay, so next is for the normal condition, we're doing means, right? This is how is the normal condition for means different than with proportions? It's substantially different, right? For proportions, the normal condition is NP n1 minus p greater than equal to 10, right? For proportions. But for means, what do we need? Yeah? Exactly. So we have to look at the data. If it's above 30, the central limit theorem kicks in and we're good. And that we like that. That's easier. If it's not, then we need to look at the shape of the data. So this goes back to what we did in chapter 1. So we're going to type in these numbers here into so stat edit, and then we're going to type in these 12 numbers, and eventually you actually get to use, when you type in these numbers, you get to look at the shape and you get to use it to find the standard deviation and the mean when you're doing your significance test calculations. 50, 46, 48. So what I recommend doing when you look at this graphically is doing the box plot that shows the outliers, because there'll be little stars if there are outliers. So I would go to then stat plot, make sure you turn it on, and go to the one that shows the outliers there, and then say graph. And usually the window settings aren't quite right, so what do you hit to make it fit? Zoom 9, right? We'll kind of do the windows for you, so zoom 9, and that'll kind of make it look right. And so you can see, so it's actually, well, the median is pretty much in the middle. So 50% of the values over here, 50% over here. It's actually a little bit, it looks like it's a little bit skewed to the left, but it's only mildly. So it is, so for the normal condition, I would say box plot shows roughly symmetric, no outliers. Roughly symmetric, no outliers, and then you should draw it. Roughly symmetric, no outliers. And then the independent condition, is that met? We have a sample of 12 hours, and you assume there are, assume more than 10 times 12, or 120 hours of music played. Hours of music played. Not during the day, during the week, right? That's what we sampled out of. So it says you randomly select 12 different hours during the next week. So there's at least 120 hours of music played during the week. So we're good on those conditions. Okay, so let's, if we were gonna do a test here, what would H naught be? So H naught is the, remember it's the statement of equality, so mu, yep, mu equals 50, right? 50 minutes of music every hour. And then the alternative, what are we looking for, hoping to show? Is that mu is it's a two-sided test if it's not equal to 50 and we don't have an inclination about which direction we want to go in. But do we know, if you read the problem again, whether it's, yeah, probably less than, because we're kind of like they don't give us the amount of music that they say they're giving us, so that's what we're trying to show, is that they actually give us less than 50 minutes. Okay, so now we need to find the test. There's two parts. There's the test statistic and then there's the p-value. So don't stop. The test statistic is how many standard deviations away from the mean. We need to find the mean and the standard deviation of our sample. So we already have the data in our calculator. We need to find x bar, the sample mean, and s sub x, the sample standard deviation. But it's all in our calculator. So you go to stat, calculate, 1 var stats, and then make sure it's list 1 is where you enter your data, calculate, and there it is. X bar is 47.9. X bar is 47.9. And S sub x is 2.81. And so our test statistic then is t is equal to how many standard deviations away from the mean. So we just do, okay, our sample said 47.9. We're going to subtract it from what was stated in H naught to be the mean, which is 50. Because we're assuming that H naught is true. So we want to know, so this is the sample mean, 47.9. It's a little bit less than 50. H naught states that the population mean is 50. So we assume that that's true. We want to figure out how far away our sample was from the actual. So, and then our standard deviation is, we're going to use 2.81 over the square root of n. Our sample size was 12. So if you carefully type that in using parentheses so that the order of operations are done correctly, you should get negative 2.59. So it's about 2.5 standard deviations below the mean. And don't forget your degrees of freedom, which is just the sample size minus 1. So the sample size was 12. So we're going to use this test statistic and 11 degrees of freedom. Okay, and minus 1, right? Sample size is 12. So we're going to use 11 to find the probability that this would happen. This isn't the answer. We want to find the probability that would happen. So the probability that t is, do I do greater than or less than? Less than, right? That's the direction that our alternative hypothesis is, less than. Probability that t is less than negative 2.59. Okay, so now we're going to use table B to look this up. And if you look in table B, we don't have any negative values for, so you go to line 11 for degrees of freedom. Go to line 11. But notice there's no negative values of t. We only have the right side. It gives you the area to the right, not to the left like we're used to in table A. Okay, it's area to the right. but it's symmetric. It's perfectly symmetric. So instead of using negative 2.59, we'll just use positive 2.59. So that is the same as the probability that t is greater than 2.59. It's because of symmetry. Write that down if you need to know why that happened. So we go to 11, and we try to find as close as we can to 2.59, and it's not actually there. It's between this, which is fine. So our value of p is between 0.01 and 0.02. So p value is between 0.01, so about a 1%, 1 to 2% chance of that happening. It's not very likely. We're probably going to reject H naught, right? And we're probably going to say the station's playing less than 50 minutes. Okay, but that's not, we end there because that was enough on that.